Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x from the left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. And 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. Now from here, I'm going to divide both sides by 3, so these two cancel out, and I get 9 to the power of x is equal to 333. Now 9 I can rewrite as 3 squared to the power of x. So I get 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x is equal to 3 to the power of 2x, which is equal to 333. And now from here, I'm going to take the log on both sides, so I get log 3 to the power of 2x is equal to log of 333. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. So in this case, I have log 3 to the power of 2x, and I can move 2x to the front. So I get 2x times log 3 is equal to log 333. Now I'm going to divide both sides by log 3 because we're isolating x. So these two cancel out, and I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in the form log a times b, this is equal to log a plus log b. So I get log of 3 plus log of 111 over log 3. And this is equal to 1 plus log of 3 plus log 37 over log 3, which is equal to 2 plus log 37 over log 3, and meaning x is equal to 1 plus log of 37 over 2 times log 3. Alright, so in this video, I'm going to solve the equation 27 to the power of x minus 3 to the power of x is equal to the square root of 2. So to solve this, I'm going to first rewrite 27 as 3 to the power of 3. So I get 3 to the power of 3 to the power of x minus 3 to the power of x is equal to square root of 2. And now from here, I'm going to rearrange these. So I get 3 to the power of x to the power of 3 minus 3 to the power of x is equal to the square root of 2. Now I'm going to let 3 to the power of x equal to the variable y. So I get y to the power of 3 minus y is equal to the square root of 2. And this means that if I square this on both sides, y to the power of 3 minus y squared is equal to 2. So now if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So this is going to turn into y to the power of 3 to the power of 2 minus 2 times y to the power of 3 times y plus y squared. And this is equal to y to the power of 6 minus 2y to the power of 4 plus y squared minus 2 is equal to 0. Now from here, this turns into y to the power of 4 plus 1 times y squared minus 2 is equal to 0, because we just factored by grouping. So now I get two equations. I get y to the power of 4 plus 1 equals 0, and y squared minus 2 is equal to 0. So for y squared minus 2 equals 0, all I have to do is add 2 on both sides, and I get y squared is equal to 2, and if I take the square root, I get y is equal to positive negative square root of 2. So this is my answer for this. These are two solutions, and for two more solutions, I'm going to rewrite this as y to the power of 4 is equal to negative 1. And now from here, I'm going to rewrite y to the power of 4 as y to the power of 2 to the power of 2. Now, if I take the square root on both sides, I get y squared is equal to the square root of negative 1, meaning y is equal to I. So, these are my three solutions to this equation. Alright, so in this video, I'm going to solve a challenging system of equations. So for my first equation, I have x plus y is equal to 4. And for my second equation, I have x times y is equal to 24. So at first glance, this might seem simple, but it's actually a lot more complicated. So I'm going to first start by using my first equation and solving for y. So my first equation is x plus y equals 24. And to solve for y, I'm going to subtract x on both sides. So I get y is equal to 24 minus x. Or sorry, it should be x plus y is equal to 4. So if I subtract x, I get y is equal to 4 minus x. So now I'm going to label this equation 3. Now that we have the value of y, I'm going to go back over here to our second equation, x times y equals 24. And if x times y equals 24 and y is equal to 4 minus x, then I get x times 4 minus x is equal to 24. And now if I distribute the x, I get 4x minus x squared is equal to 24. And now I'm going to subtract 24 on both sides. So I get negative x squared plus 4x minus 24 is equal to 0. Now I don't want my coefficient for my highest degree term to be negative. So what I'm going to do is I'm going to multiply both sides by negative 1. So now if I distribute this, negative x squared is positive x squared, negative 1 times 4x is negative 4x, negative 1 times negative 24 is positive 24, and 0 times negative 1 is obviously just 0. So I get x squared minus 4x plus 24 is equal to 0. Now we have a quadratic equation, so to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 4, and c is 24. So I get x is equal to negative 1 plus positive 4 plus or minus the square root of b squared, which is negative 4 squared, which is 16 minus 4 times a, which is 1, times c, which is 24, all over 2a, so 2 times 1. Now this is equal to 4 plus or minus the square root of 16 minus 24 times 4 is 96, all over 2, which is equal to 4 plus or minus the square root of negative 80 over 2. Now, the square root of negative 80, I can rewrite as the square root of 80 times the square root of negative 1. And before I do anything with the square root of negative 1, I'm going to first simplify the square root of 80. So the square root of 80 is equal to the square root of 16 times 5, which is equal to the square root of 16 times the square root of 5, which is equal to 4 root 5. So I get x is equal to 4 plus or minus 4 root 5 times the square root of negative 1 over 2. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I get x is equal to 4 plus or minus the square root, 4 root 5i over 2. And now I can divide both these terms by 2, so I get x is equal to 2 plus or minus 2 root 5i. So this means that I have two solutions of x. I have x is equal to 2 plus 2 root 5i, and x is equal to 2 minus 2 root 5i. And for each of these solutions of x, I need a solution of y, because remember, we're not just solving for x, we're solving for these solution of x and y. So recall how y is equal to 4 minus x, meaning y1 is equal to 4 minus 2 plus 2 root 5i, which is equal to 4 minus 2 root 5i, which is equal to 2 minus 2 root 5i. And for y of 2, I get 4 minus 2 root 5i, which is equal to 4 minus 2 plus 2 root 5i, which is equal to 2 plus 2 root 5i. So my solutions are, I have two solutions, 2 plus 2 root 5i, comma, 2 minus 2 root 5i, and 2 minus 2 root 5i, comma 2 plus 2 root 5i.